Welcome to the CSI Fraud. We are the data detectives, and this is our project on active learning for credit card fraud detection. In this project, we demonstrate that by being smarter about which transactions we choose to investigate, we can catch significantly more fraud without spending a penny more on the budget. Our case file contains 284,807 transactions. Hidden inside are only 492 frauds. That is a fraud rate of just 0.17%. It's a massive needle in a haystack problem. The core challenge is that acquiring labels for this data is expensive, since getting that label requires a manual investigation by a human analyst. Since human resources are limited, we are strictly capped at a budget of 5,000 investigations. If we just pick random transactions to investigate, we will waste that entire budget checking innocent people and miss the actual criminals. So, our goal is to use pool-based active learning to intelligently decide exactly which 5,000 transactions to send to the analyst, maximizing the number of frauds we catch under the same fixed budget.
Okay, so the first detective in our story is the rookie, who uses random sampling. He picks transactions uniformly at random with no sense of risk or structure in the data. After spending the full budget of 5,000 investigation, this strategies finds only about 89 frauds, so most of the budget goes to easy legitimate cases. We then moved to pool-based active learning with a light GBM model. We started from 1,400 labeled transactions, and in each round, we add a batch of 400 labels until we reach 5,000. Our standard detectives are entropy, margin, query by committee, and a cost-balance entropy variant that already includes a simple fraud prior. They follow the same loop. Try on a label seed, score the unlabeled pool, pick the next batch to label, and then retrain. They perform much better than random. For example, query by committee finds around 280 frauds at 5,000 labels. But under such extreme imbalance, even that still leaves many cases undiscovered.
To go beyond generic uncertainty, we introduced fraud-aware scores. The fraud scores combine model uncertainty near the decision boundary, a fraud prior that boosts likely positives and the distance to the decision threshold we care about. Fraud++ add a rarity boost, so rare but high-risk transactions get higher scores and can reveal new fraud patterns in sparse regions of the feature space. On top of Fraud++, we define two hybrid specialists. Fraud++ hybrid mixes normalized Fraud++ score with query by committee disagreement, and then selects a diversity batch in a PCA space. Graph hybrid builds a k-nearest neighbor graph over the most suspicious points, add hub scores for dense clusters, and bridge scores for connectors between regions, and combine this with Fraud++ QBC disagreement and diversity. These two hybrids are the main methodological contribution of our project.
All strategies share the same experimental setup. We run 3 random seeds and grow the labeled set from 1,400 to 5,000 transactions in steps of 400. Keeping the light GBM hyperparameter fixed across all strategies to isolate the effect of the acquisition function. We evaluate our detectives with fraud found as function of labeled, AUPRC and AUROC, and recall and precision at 0.1% false positive rate. This lets us compare both the final performance and the label efficiency of each strategy.
This bar chart shows how many frauds each strategy finds at 5,000 labeled transactions. Random sampling reaches about 89 frauds, while query by committee reaches around 218 frauds. Our specialists Fraud++ hybrid and graph hybrid reaches up to around 352 frauds with the same label budget. Compared to random, this is roughly 296% increase, in front fraud, and compared to query by committee, the hybrid still finds about 61% more frauds. So just by changing the strategy, we catch many more frauds without increasing the labeling budget.
In terms of AUPRC, the fraud-aware strategies reach strong values with fewer labeled transactions than entropy merging or random sampling. That means they are both more accurate and more label efficient. They use less human effort to reach the same quality level. To conclude, our data specialist, Fraud++ Hybrid and Graph Hybrid turn the same 5,000 manual investigation into many more confirmed fraud cases. They show that fraud-aware hybrid active learning can turn a fixed labeling budget into substantially better rare event detection, making a strong case for using smart active learning in real fraud review teams.
And just like that, my friends, case closed.